This is Precal Academic, Period A, Tuesday, August, the 29th? 30th. Tuesday, August 30th. We're starting on P7 in the Unit P notes under heading 2, solve with no calculator. All right. Hey, we're going to solve with no calculator. We're going to find all the x such that x squared plus 7x plus 12 is less than 0. Okay? Anyone remember how to do these from Algebra 1? Yes?
You still set it up when it's like
Yeah, so we still want to find, basically what we want to do is want to just sketch the way I like to do it is I like to sketch a quick graph of this parabola. To do that, you only really need to know two things. You need to know which way the parabola faces, whether it's upward or downward, whether it opens upward or opens downward. And you need to know where the zeros are. The zeros are where the parabola intersects this horizontal axis, okay? So we find that by finding the zeros of this quadratic. Okay, so we can factor this. Does anyone know how we can factor it? X plus 4 and x plus 3, is that what we said? Nice. Yep, so we can factor this into x plus 4 and x plus 3. Okay. So we're going to go over here. Where am I going to plot my zeros? -4, -3. So this is going to be a subpar sketch. Okay, so this is a -4, -3. Is my parabola going to go open upward or downward? How do I know? What's positive? Yeah, so the number in front of my x squared term is positive, right? It's positive 1. So what's going to open upward? Okay? If the number in front of my x squared term is negative, then it opens downward. Okay? But for this one, it's positive, so it opens upward. Alright, I'm a terrible artist, but I just need a sketch. I just need a rough sketch. Alright, so I have, this is x equals -4. X equals -3. Okay, and what am I looking for? I'm looking for all the x such that what? Such that what? Less than 0, right? So where am I less than 0 then? Where's my parabola less than 0? Everywhere?
Oh, I thought you meant like.
Where's my parabola less than 0? Yeah, so right where it dips below the x-axis is where it's negative. Right, and that's between my two zeros. That's between my two zeros. So what's my interval then on which, this is less than 0? What's my interval for my x's then that solve this inequality? So it's going to be -4 to -3, right? So we'll make sure we understand this. When x is greater than -4, right, we're in this region right here. My parabola is below the x-axis. When it's less than -3, we're still in this region. Okay, it's below the x-axis. Okay, is anyone confused on how that works? This is my solution. Yeah, all the x's from between -4 and -3 exclusive. Why do I have parentheses and not square brackets? It's less than 0, right? So at -4 and at -3, my expression on the left is equal to 0, but that's not what we're looking for. We're looking for less than 0. So maybe I'll make these hollow circles to make it easier to see. Okay, are we okay with that? I find it easier to graph if I graph it.
Okay, but you won't get one off.
If you don't, no, if you either answer, you don't, you're fine, but. All right, so what's this next one? We want all the x such that x squared minus 16 is greater than or equal to 0. All right, quick factor. What do I have here? What kind of factoring problem? So, it's a difference of squares. Anyone remember difference of squares from Algebra 1? How do I factor x squared minus 16? Yeah, okay, good. So we know how to do it. Okay. X minus 4. So this is, we want all the x such that x minus 4 times x plus 4 is greater than or equal to 0. Okay? What does this graph look like? where am I going to plot my zeros? Am I going to do solid dots or hollow circles? Solid dots, right? I'm going to do solid dots because this is an OR grade. This is a greater than or equal to. And then where are my two zeros? Where do I cross the x-axis?
Negative 4 and positive 4.
Negative 4 and positive 4. Right? And do I open upward or downward? Upwards. Why do I open upward? Positive, right? The x squared term is positive. So I'm going to open upward. Okay? And I want, so which regions of the x-axis then am I going to?
Negative 4 and positive 4.
So between? Who thinks I shape between? Yeah, Maddie? Yeah, I do. Yeah, sorry, my bad. So I want all the x such that my parabola is above the x-axis. I want everything right, I want greater than or equal to 0. So I want all of these x's. Okay? Does that make any sense? I want everything where the parabola's above, right? And it's below in between them. Below in between them. Okay? And I'm going to include my two endpoints here, my 2 points. X equals negative 4, x equals positive 4, okay? So how do I write this in interval notation? So negative infinity, that gets a parenthesis, right? To what? Negative 4 with what? Square bracket. And then,
Can you explain how you're shading the outside?
yeah, so I want all the x such that x squared minus 16 is greater than or equal to 0, right? So I want everywhere where the parabola, where this function on the left is greater than 0. Okay?
Above, like, above the line.
Yeah, above the line, above the x-axis, right? It only dips below in this region right here. So I want to the right and to the left of it. Yeah.
Is that always if it's that sign, it's gonna be something like that? Or is there just exceptions to this?
If it's what sign? Sorry. The union
equal
sign?
To, no, the equal to or
Is it always going to be what?
like a union.
So in here, I haven't seen any intersection. So for these, I would do union. Yeah. And do it. There's a seat in the front.
Yeah, I got you right there.
Oh, I'm sorry. All right, are we okay with that one? So union means or. So we're either going to go negative infinity, negative 4, or positive 4 to infinity, okay? All right, I'm going to move on to C. Move on to C. Okay? We want all the x such that x cubed minus 4x is greater than 0. It's greater than 0, okay? Uh-oh, we got a cube here. Scary. Okay, so how do we graph this by hand? How do we sketch the graph of this by hand? So, first thing I want to do, right, so hopefully we remember this. Actually, we've never, we go over this in Algebra 2, I don't know. Okay, so, to sketch my graph, what I need to do is I need to get all my zeros right. And I need to get my end behavior right. So as x goes to negative infinity, what's my function doing on the left? As it goes to positive infinity, what's it doing, right? Okay. So first off, what I know is that this is an odd degree polynomial. Okay, odd degree polynomial. Why is that odd degree? Yeah, the highest exponent is 3, which is an odd number. Okay? So what is the end behavior then? what does that tell us about the end behavior?
The degrees are gonna be opposite.
Yeah, so the end behavior is going to be opposite. So I'm going to have, as x goes to negative infinity, I'm either going to go down or up, right? And then as it goes to positive infinity, my graph's going to do the opposite of what it does over here, okay? Okay, so the coefficient, how do we know whether we start at negative infinity or positive infinity? How do I know?
The coefficient is one that has to be
So the coefficient of the highest degree term, right, of this x cubed term, is it positive or negative? Positive, right? It's positive. What that tells us is that we're going to start from negative infinity and we're going to end at positive infinity, right? So we know there's opposite end behavior because it's an odd degree polynomial. And we know we start at negative infinity and end at positive infinity, right? Because the coefficient of my x cubed term is positive. If you think of like the function y equals x, this is technically the same thing, right? It has a positive slope, so you go from negative to positive, right? That's the way I remember it, right? Or if you think about y equals negative x, right? Coefficient of the highest degree term is negative. Has a negative slope, starts from positive, goes to negative, okay? So then the next step is I need to plot my zeros. So how do I find the zeros of this function? Does anyone know?
It's x minus 2 and x squared plus
0,
So I don't know how to, it's hard to just straight up factor cubic polynomials, but right here I can pull out a factor of x, right? So I'm going to start by taking out the greatest common factor of these two terms, which is x. This becomes x times x squared minus 4 greater than 0, right? And then what does x squared minus 4 factor to? X plus 2 and x minus 2. So what are my three zeros? And do they get open circles or solid dots? Open circles. So I'm going to have 0. I'm going to have negative 2. I'm going to have a positive 2, okay? So I know this graph comes from negative infinity, hits the horizontal axis right there. What does it do after that? Does it go straight through the horizontal axis or does it come back down? How do I know it goes straight through? So there's two ways we can figure this out. We can plug a number between negative 2 and 0 into our function and see where it is. So if I plug negative 1 into x cubed minus 4x, I get negative 1 plus 4, which is 3, so I know it goes through.
So it's odd, you go through.
Yeah, have you guys talked about the multiplicity of zeros?
Yeah.
You talk- Yeah, the other way I can tell is I can look at the multiplicity of my zeros. What does that mean? What does that mean? Big word, big phrase. Yeah, so my zeros, right, are negative 2, 0, and positive 2, right? The multiplicity of my zeros refers to the exponent of each factor here once I've completely factored my polynomial. So my 0, negative 2 that we're looking at right here, the multiplicity of that is 1 because I have an exponent of 1 here when I factor it out. The x plus 2 factor gets a 1, has a 1 in the exponent. It's an odd number, so what that means is the graph goes straight through that 0. Okay? My art skills are terrible. I just need a rough sketch of this graph because I just need to know where it's above and below 0. Okay? What about so then it goes back down to 0. Does it go straight through 0 or just come back? Does it curve back up? Straight through, right? And why is that? Because my x factor has an odd exponent. Its exponent is equal to 1. So it goes straight. That goes straight through. And then I come back up here to positive 2. X minus 2, what's the multiplicity of this 0? It's 1, right? So it's odd, so it goes straight through. Right, and then my end behavior as it goes to infinity is positive infinity, okay? So we want what? We want everywhere where what is the case? Where my curve is above the x-axis, right? We want to know the parts. We want to know that the x's that make this left side greater than 0, that's everywhere my graph is above the x-axis. So what are my two intervals going to be where that's true. So here's negative, x equals -2, x equals 0, x equals +2, right? So where are my intervals where the graph is above the x-axis? Where are my intervals what are my intervals for x where my graph is above the x-axis? Parentheses or brackets? Parentheses. And then union to positive infinity. Okay? Right, I'm above the x-axis at -2 and 0 because I have hollow circles, I give them parentheses. And I'm above the x-axis from 2 all the way to positive infinity. And my 2 gets a parenthesis because it's a hollow circle. Okay? Yeah.
I think you said this, but how do you know if the first one goes up or down and then like second?
Yeah, so we know the end behavior is opposite, right? Because I have an odd degree polynomial. We know we start at -infinity and end at positive infinity because the coefficient in front of my cube term is positive.
So if it was -6,
It would start at positive infinity and end at negative infinity. Right, and there's an analogous example when we think of the graph of y equals x, right? That's positive coefficient in front of x. Positive slope starts at -infinity, ends at positive infinity. Same thing for y equals -x. Negative coefficient, negative slope starts at positive infinity, ends at negative infinity. Okay? We feeling okay about that? Okay, let me move on to. Right, so there's a lot of things we need to remember for those, but each individual piece isn't too complicated. There's lots to remember. You got to graph the end behavior, you got to graph the zeros, and then you got to graph the correct behavior around my zeros based on the multiplicity of that zero. Part D. D's same deal. We want all the x such that x cubed minus x squared minus 30x is less than or equal to 0. So I'm going to start with my what? What do I want to start with? My end behavior. What's my end behavior here? Rylan, do you know my end behavior? Yeah, so it's going to start where? As I go to -infinity, where does my graph go? Nice. And the other side, yep, it's going up. Good job. Right, I have an odd degree polynomial. My highest exponent is 3. And then my coefficient here is positive. So I'm going to start at -infinity as x goes to -infinity. And then as x goes to positive infinity, I'm going to end at positive infinity. Okay, zeros. How do I start finding my zeros? Ava? Yeah, so I'm going to factor out an x. So I have x times x squared minus x minus 30 is less than or equal to 0. Okay, I can factor this. I can factor my quadratic here to x minus 6 times x plus 5. So what are my 3 zeros then? So I have 0, 6, and -5. Okay, these are my 3 zeros. Do I give them solid dots here or hollow circles? Solids, right? It's like less than or equal to, so I give them solids. So I'm going to 1 at 0, 1 at -5, 1 at positive 6. Okay? And what does my graph do at all my zeros? Does it go straight through or does it just go touch and then come back down? How do we know? It goes straight through the horizontal axis. And how do we know that, Elise? Odd multiplicity, right? Each zero, each factor for my zeros has an exponent of 1, which is an odd number. So the odd multiplicity, they're going to come straight through, and straight through, end at positive infinity. Okay, so we want all the x such that what? We want all the x where my graph is less than or equal to 0, right? So what are my 2 intervals for that? What intervals is my graph less than or equal to 0, below the x-axis? Maddie, do you know? Where, at what intervals of x is my graph below the x-axis? So this is -5. This is x equals -5 right here. That's where it's above. I want where it's below. All right, someone to help Maddie out. Maggie? Yeah, so from -infinity to 5, I'm below the x-axis. Does 5, what does 5 get, Maggie? Square bracket, right? You got a solid dot there. It's a great less than or equal to? Oh, -5, thank you. Thank you, Ben. Yep, and then a union symbol. Union symbol, what's the other part where it's below the x-axis? 0 to 6, yep. And those both get what? Square brackets. Let's make sure we understand that. Any other questions on this one? Alright, so let's make sure. Alright, so I'm ready to flip my page over. Flipping my page over. Part E. Part E. I want all my x such that x squared minus 8x plus 16 is less than or equal to 0. Right? Can I factor this? I can. Does anyone know, real quick, does anyone remember from Algebra 1 how I can check whether a quadratic can be factored? Anyone remember how to check? Anyone learn that trick? Okay. So if we remember the quadratic formula, x equals the opposite of b plus or minus the square root. B squared minus 4ac all over 2a. Okay? This number right here, just the b squared, let's take this out, b squared minus 4ac. This is called the discriminant. You don't need to know that word, but I'm going to refer to it as the discriminant. Right? So if we calculate b squared minus 4ac, what's b squared minus 4ac here? We get -8 squared minus 4 times 1 times 16. What is that? 64 minus 64? So it's 0. So if my discriminant, if it's a perfect square, then I can factor my quadratic. Is it a perfect square here? Is 0 a perfect square? Yeah. What's the square root of 0? 0. Yeah. Nice job. Yeah. So it can be factored here. It can be factored. Okay. So I'm going to factor it into x minus 4 and x plus 4. No, it's x minus 4 twice. X minus 4. So what does my graph of my quadratic look like? It's a parabola, right? Does it open upward or downward? How do we know it opens upward? Because this number in front of my x squared term is positive, so it opens upward. And then where's my 0? Where's my 1, 0? Positive 4. Does that get a solid dot or a hollow circle? Solid dot, right? It's a less than or equal to, so it gets a solid dot. Okay. I want all the x such that where my graph is below the x-axis or on the x-axis, okay? Is there anywhere where it's below the x-axis? No. There's only one spot where it barely touches that. What x is that? That's my x equals 4. Yeah. That's the only spot where everything on the left is less than or equal to 0. So that's my solution, okay? And notice key has 4 written in a set by itself, so it's just the set of numbers containing only 4. It's kind of, if you write x equals 4, either of those I'll take. So x equals 4 is the only x value that we can plug into the left side of this inequality and get a value that's less than or equal to 0. Yes, stop there. Yeah. Okay. We okay with that? So if we're not quite getting it, now's the time to speak up. Are we okay if I move on to F? So F, x squared plus 9 is greater than 6x. What's the first thing I want to do with this function? Yeah, so I want 0 to be on one side by itself. So to do that, I subtract 6x for both sides. So I get x squared minus 6x plus 9 is greater than 0. Greater than 0. Can I factor this? Can I factor this? Yep, right. So I do b squared minus 4ac. I get 0 again. I get 0 again, right? What does this factor to? Anyone know? X minus 3 times x minus 3. Alright, I'm still greater than 0. So what does my parabola look like, Reese? Do you know?
It opens upward.
Opens upward, yep. So the number in front of my x squared term is positive, so it opens upward. And where's my 0? 3. Is that get a hollow circle or solid dot? Hollow circle, right? It's just greater than, so it's a hollow circle. So x equals 3. And it opens upward, right? That's all I need to sketch. That's all I need to sketch. We want all the x such that what? Such that we're greater than 0. What interval is that? Caleb, do you know? Negative infinity to positive infinity? It's close. Very close. There's one number or equal to 0, right? Yeah. At x equals 3, the left side of this is equal to 0, so it doesn't satisfy the condition that's greater than 0, okay? So we're going to go negative infinity to 3 with a parenthesis since 3 is not included, and then 3 to positive infinity. You okay with that? So we go negative infinity, right? We want to know we're above the x-axis, so it's negative infinity all the way to 3 where it touches the x-axis, and then all the way to positive infinity. 3 to positive infinity, okay? All right, get your graphing calculators out, please. Yes. So my inequality symbol is just greater than. Just greater than 0. So anywhere where the function on the left is equal to 0, it doesn't satisfy my inequality. So my 0 right here. So here it got a less than or equal to. It lies with the sign. So this has a less than or equal to symbol. So I want everywhere where this graph either touches the x-axis or is below the x-axis, and it touches the x-axis at exactly one point, x equals 4, right? And it's never below the x-axis, so x equals 4 is my 1 point. Over there, they're asking for greater than 0, right? So there's almost the same graph, right? But they want, it's just the inequality symbol is different. So they want everywhere where it's greater than 0. Okay? So it's greater than 0 literally everywhere except where it touches the x-axis, right? And that's what x equals 3. So that's why My answer is all reals except. No, you need both because everything's to the left of 3 satisfied.
Oh, it's like
Yeah. Everything but 3, okay? Let's get our graphing calculators, okay? And we're going to solve these now with calculators. So it makes our life a lot easier using calculators. Okay? Yeah. Yeah. If you guys don't have a graphing calculator, you need to get one, okay? You need to get one. We need to know how to use these. You're going to be asked how to use it on a test. So you need to get them. Alright, there's an app called Calculate 84, right? Is that pretty similar to a graphing calculator? Same thing? Yeah, so you want to get your iPad out and open up Calculate 84 and download it real quick. I'm fine with that. We need to start learning how to use our graphing calculators. So I'm going to use Desmos just so you can see it on the board. Okay, so parts, we're on heading 3, part A. We want all, so I'm going to graph 4x squared minus 12x plus 7 plus 7. Okay, does anyone have trouble putting that in their graphing calculator? So we're going to graph 4x squared minus 12x plus 7 in our graphing calculator. Okay? Does anyone remember how to find zeros with your graphing calculator?
Second calc.
Yeah, so if I have my graph, if I have my parabola graphed in my calculator, right? If I have that parabola graphed in my calculator, I'm going to hit second calc and go to calculate 0. Okay, it's going to give me that cursor. My right and left arrows, let me move my cursor around. Okay, so for each place, each spot where it crosses that horizontal axis, I'm going to take my cursor and click to the left of each intersection with 0. And I'll click to the right of that intersection and hit enter again when guess pops up. It's going to tell me my 0. What's that first 0 on the left? 0.793, right? You should get about 0.793. Okay? You have trouble? Okay. Alright, and then we want to find that other intersection, so we get second calc again, second calc, and then the 0 option, that's number 2. Scroll over to that right, the 0 on, scroll over to the 0 that's over here. Click with my cursor to the left of it, so click like somewhere down here. Scroll over with the right arrow over here, and hit yes. It'll give you my other 0. I'm finding 2.207. Is that what you guys are finding? No? Okay. Okay, so this other one is 0.207, okay? And what's that problem asking for? It's asking for all the places where the graph is above the x-axis or below the x-axis? What's my problem asking for? Below, right? Less than 0, it wants 4x squared minus 12x plus 7. It wants to know where this graph is below 0. Okay, so that's in between my 2 points. So what's my interval here then? What are the 2 endpoints of my interval? 0.793. And then it goes below, all the way in between those 2, to 2.207. Okay, do I get parentheses or square brackets? For this one we're doing right now. So this gets parentheses. So the inequality symbol is less than 0. So my endpoints where it's equal to 0, they're not included. Yeah. Yeah. Okay, are you guys ready to move on to that next one? Ready to move on to that next one? Okay, part B. Part B, okay, x squared minus 4x is greater than 1. What do I do first? What do I graph? What do I plug in my graphing calculator? So we're going to do, I'm going to subtract over a 1 first. Are you guys okay with that? So I'm going to plug in my graphing calculator, x squared minus 4x minus 1. Subtract over the 1 and get x squared. Get x squared minus 4x minus 1 is greater than 0. Okay, so I'm going to put that in my graphing calculator. Okay, graph. Can I get that little parabola to show up? Okay, then I'm going to hit second calc. 0. My cursor pops up. I click to the left of that first intersection with the x-axis, and to the right of it, and I hit guess. What do I get for my first 0? Negative 0.236. And what do I get for my second one? .236. All right, so your graphing calculators, actually I'm up here. All right, so I want, what's my inequality symbol say? What is it? It's a greater than, right? And it's just a greater than. So I want the parts of the x-axis, I want to show you the parts of the x-axis where the graph is above or below the horizontal axis. Is that? Above, yeah. I want everything where the graph is below the x-axis. So what is that? Negative infinity to my first 0 here, and then from my second 0 to positive infinity are where my parabola is above the x-axis, okay? So my interval is negative infinity to negative 0.236 with parentheses, union 4.236. Anyone confused by that? All right, Ian, yeah, okay. You do a union, no. So you do a union whenever there's, so we have two intervals, right? We have an interval coming from here to here. Now you understand like why both my intervals solve it, but they're not connected. They're not, there's a gap in between them, so then we do a union. When it what?
When it doesn't have
When it's not, they're not connected. Those two regions are not connected. No, like that's no. So, do you see how each of these intervals individually solves this? So each of these intervals, where we need to know both of them. So if there's two intervals that both solve it, we just say that they both solve it by putting u in between. Yeah. Right. Why do we have to write them as two separate intervals? We have to write these two, right? They both solve my inequality. Why do we have to write them as two separate intervals? Not just because it's a greater than, because they're not connected. Because they're not connected, right? There's numbers between negative 0.236 and 4.236 that are in our solution region. So we can't include those. So we have to write it as two different. An interval going from here to here and here to here. Because so we know they're not connected because there are numbers in between their endpoints that are not in my solution set that don't solve my inequality. So there's a gap right here. There's a gap right here.
I see that.
Yeah, that's why we know they're not connected. There's a gap, but they're not connected. All right. Come to office hours if we're still confused about that. Okay, let's move on. Okay, we gotta move on. All right, part C. X, 8x minus 2x cubed minus 1 is less than 0. So let's graph that. This here will be another one, Maddie. What's my inequality symbol? It's a less than, right? Well, everywhere where this graph is less than 0. Okay? So you gotta go and find your zeros, find all the zeros, and write with your calculator and write them down. Yeah, they don't have trouble doing that. This is hard. So find those zeros real quick, write them down. So on our graphing calculators, we get do I get solid dot? Do I get these solid dots or hollow circles? Hollow circle. It's less than, right? It's a less than symbol. So negative 2.06. Positive 0.125. And positive 1.934. We want everywhere it's below the x-axis. What are my two regions? Where my graph is below the x-axis. So everything in between here, right, it dips below. And then everything, right, goes below onto infinity. So Maddie, this is going to be another example, okay? My two regions that solve this inequality are negative 2.06 and 0.25. So you see how that solves it? But let the graph dips below the x-axis on this circle. And then my other one's going to be 1.934 positive. Okay. Right? So that both these intervals solve my inequality, and then there's a gap in between them. So I gotta write a U. I have to write them as two separate intervals. Right? So the U is like saying and. This is like saying this interval solves it and this second interval solves it. Does that help at all? Okay. Are you guys okay if I move on to D? Okay, so D, we have x squared plus 12x plus 4 is greater than 0. Okay, so we can let's graph that on our calculator. Graph on our calculator. Let's try to find the zeros of that. Our calculator. basically we're doing these graphing calculator problems just like we did the other ones, but our graphing calculator is doing the graphing for us. Convenience. Just convenience. Right. So do we have any trouble finding that 0? Right, so it opens, goes to negative 2/3. Is that negative 2/3, is that 0 get a solid dot or a hollow circle? Solid dot, right? It's got an or equal to line. Right? So we want everywhere where the parabola is where? Below or above the x-axis? Above, right? It's greater than or equal to. Where is that? Negative infinity to where? Positive infinity, right? We're looking. The problem's asking for everywhere where this parabola is above or on the x-axis, right? That's everywhere, right? It's every single number, every single x that we can plug into this function. Every single x that we can ever dream of plugging in gives us a number that's greater than or equal to 0. Okay. So what's my solution? How do I write an interval notation? Negative infinity is positive infinity. Okay. Am I going too fast, too slow? Yeah, I probably wouldn't count on.
Yeah.
I probably wouldn't. Yeah. You're good though. Yeah, because that set that you is the same as this. All right, so what is this class guys? You got it at 40?
Yeah.
Okay. Let's go ahead. You guys have that number 33 number in there? You don't? Okay, I'm not going to mess with that. It's technical problems. All right. Let's go ahead and stop there then.
We need the technical problem for the homework though.
What's the homework say?
It's the story word problems. We need to show the textbook problems.
Yeah, so that's important. We have been doing word problems here. And that's fine. I want to start doing that. So then for next time, guys, we meet tomorrow. What due tomorrow? We'll have P7 homework, okay? P7 due tomorrow. P7 due tomorrow. And then those book problems. Yeah, let me make sure. Oh, no, they're sweet. Okay, yeah, so go for it and see what you can do, okay? We have 4 minutes. Do you want to do that first one together, number 2? Okay. Okay, so I'm looking at number 2 of the P7 homework. An open top box is made from a 20 by 22 inch piece of paper. By cutting congruent squares, each corner is fully of the resulting flats. What size squares will give a volume of at least 283 cubic inches? Alright, so we have a box.
So 283 equals 25.
Piece of paper, piece of cardboard, right? Or a piece of paper, it's 20 inches by 22 inches. Right? Right, and then we cut squares out of the corners. They're squares, so these two lines are congruent. Right, so let me, the problem's asking for what? Whenever you start a word problem, the most important thing to do is to look for what they're asking for. They're looking at what size squares. They're looking at what size squares. They're essentially asking us what length of this x. If I call this x, the length of each square I cut in, what length is going to give me a volume of at least 283 cubic inches, right? So what will, when I take my box and I fold these flaps up, I'm gonna have a box, right? My little box.
So if you just take the 25, 22 multipliers, that's 283 probably. Divide that by 4.
Right, so the length of my box will be what? It'll be 22 minus what? What am I cutting off from the length? I'm cutting off 2x from it. What will the width be? 20 minus 2x, right? I'm cutting an x off here and an x off here, so 20 minus 2x. And what will the height be? The height will be what? It'll just be x, right?
Yeah.
The height will be equal to x. So what's the volume of my box equal to? So, right, length times width times height, so it's going to be 22 minus 2x. 20 minus 2x times x.
So 440 minus 5x.
And we want that to be what? What do we want to be true about the volume?
440 plus 5x.
Greater than or equal to 283. You want that volume? So that's how you'd set that one up. And you solve for x. But you would throw all the x that are what? If x is negative, you got to throw it out, right? Because you can't cut a negative. So take all the ones that are 0 or positive. The key's on Schoology, so